I'm on page 228. This is screencast number 2 for Unit 5, Lesson 1. What conditions are affected by the tilt of Earth's axis? Well, we're going to find out that two things primarily are affected by the tilt of the Earth's axis. Number one is the temperature, and number two is the amount of daylight hours. And we're going to find, as we go through this lesson, that it is the number of daylight hours and how directly we're receiving sunlight that's going to help to determine the seasons that we experience. Okay, so I'm on 228. Earth's axis is tilted at 23.5 degrees. Earth's axis always points toward the North Star as Earth revolves around the sun. Okay. During each revolution, the North Pole may be tilted toward the sun or away from the sun. As seen below, when the North Pole is tilted towards the sun, the northern hemisphere has longer periods of daylight and more direct sunlight than does the southern hemisphere. When the North Pole is tilted away from the sun, the opposite is true. So if you look at the diagram, the greenish blue shows you the orbital path of the Earth as it moves around the sun. Okay? This dashed line right here shows you where the axis should be if the rotational axis and the orbital path were perpendicular. Okay, if those two were perpendicular, we wouldn't really experience seasons for the most part. It is because the axis of rotation is tilted away from this line by 23.5 degrees that we experience the seasons. Because as the Earth moves around the sun, and that axis is constantly pointed off in the same direction towards the North Star, depending on the time of the year, sometimes the northern pole is tilted more towards the sun, sometimes the southern pole is tilted more directly into the sun, and that's how we are going to get our seasons. All right. The North Star is just simply the star that is directly above the North Pole. So for instance, if you were standing at the North Pole and you looked directly overhead, the North Star would be there. Okay, always, always, always. The North Star, a lot of people think it's the brightest star in the sky. It's not the brightest star in the sky. It's not very bright at all, although you can find it. But it's noteworthy because it is the star that is directly above the North Pole. All right, let's go to talking a little bit more about temperature. The angle at which the sun's rays strike each part of Earth's surface changes as Earth moves in its orbit. When the North Pole is tilted towards the sun's rays strike the northern hemisphere more directly. Because of this, the region receives a higher concentration of solar energy and is warmer. When the North Pole is tilted away from the sun's rays strike the northern hemisphere less directly. When the sunlight is less direct, the solar energy is less concentrated and the region is cooler. Okay. Now I know who you're talking about. Okay, I just didn't realize that was his. Okay. 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 All right, now I'm understanding because I thought you were handing me 3 that did not include him. Got it. Thanks, Karen. All right, the spherical shape of Earth also affects how the sun warms up an area. Temperatures are high at point A in that diagram. This is because the sun's rays hit Earth's surface at a right angle and are focused into a small area. But towards the pole, like location B, the sun's rays hit Earth's surface at a lesser angle. Therefore, the rays are spread out over a larger area and the temperatures are cooler. Okay. Look at page 229. Remember, we're answering the question, what conditions are affected by the tilt of Earth's axis? Okay, conditions affected by the tilt of the Earth's axis. Number 1, temperature is affected by the tilt of the Earth's axis. And number 2, the amount of daylight hours are also affected by the tilt of the Earth's axis. So I'm now on page 229. All locations on Earth experience an average of 12 hours of light a day. However, the actual number of daylight hours on any given day of the year varies with location. Areas around the Earth's equator receive about 12 hours of light every day. Areas on Earth's surface that are tilted toward the sun have more hours of daylight. These areas travel a longer path through the lit part of the Earth. than areas at the equator. Areas on the Earth's surface that are tilted away from the sun have less than 12 hours of light a day, and these travel a shorter path through the lit part of the Earth, as shown below. Okay, you'll understand what they're talking about a little bit better as we do some of the activities that we're going to do later this week. But please understand that if you took the number of daylight hours for a specific location over the course of an entire year, it would average out to about 12 hours a day. Okay, here at 30 degrees north latitude in the Central Texas area where we are, our longest days in the summertime are about 14 hours, and our shortest days in the wintertime are about 10 hours. But if you took all of the daylight lengths for the whole entire year, you'd wind up with an average of about 12. Okay, and that's for 30 degrees north. If you were living at the equator, you'd pretty much have 12-hour days all the time. If you were living closer to the poles, you would still average about 12 hours a day if you took them all and averaged them out over the course of a year, but there would be more variation. You would have even longer days in the summer and shorter nights, and shorter days in the winter, etc. Okay. Look down at the bottom where it says midnight sun. When it's summer in the northern hemisphere, the time in each day that is light increases as you move north of the equator. Areas north of the Arctic Circle have 24 hours of daylight, and that sometimes is called the midnight sun because the sun is up 24 hours a day. Okay. We're going to see why that's possible again as we do some of the activities that we're going to do later in the week. Okay. Let's go and answer number 8, 9, and 10, and then I'll show you all of the notes and things that I made. Number 8, which location on the illustration of Earth below receives more direct rays from the sun? That's going to be location A, because the sun is hitting directly, beating directly down from overhead. Okay. Which location is cooler? That's going to be B, because the sunlight is hitting at a shallower angle and is spread over a larger area. The sunlight is less intense. Number 10, why isn't the area in the photo very warm even though the sun is up all night long? Well, if this was like an Arctic location, the sun may be up for 24 hours, but it's never very far above the horizon. So if you think about how far the sun is above the horizon at, like, I don't know, 7:30 or 8 in the morning, it's not very high in the sky yet. Okay, and it never gets very high in the sky at an Arctic or Antarctic location. Okay. All right, let's show you some of the notes. Okay. So I've highlighted where it says the Earth's axis is tilted at 23.5 degrees. Earth's axis always points toward the North Star as Earth revolves around the sun. The North Star is also officially known as Polaris. Polaris is the actual name of that star. We just call it the North Star because it's the star that's directly above the North Pole. And I drew a little illustration. It's like if you took the two little stars at the end of the cup of the Big Dipper and you followed a line, it would take you to the North Star. But anyway, that's not important for right now. Okay? And then I did some highlighting down here. When the North Pole is tilted towards the sun's rays strike the northern hemisphere more directly. When the sunlight is less direct, the solar energy is less concentrated and the region will be cooler. Temperatures are high at point A in the diagram because the sun's rays hit the Earth's surface at a right angle and are focused into a small area. Okay. Remember, we are looking at what conditions are affected by the tilt of the Earth's axis. Temperature is affected by the tilt of the Earth's axis, and the number of daylight hours are affected by the tilt of the Earth's axis. Okay. Now, I do want you to make a little bit of a correction on these two globes. I don't like the way that they drew the little stick figures because it's actually erroneous, meaning they didn't draw it correctly. First of all, I went ahead and did a dashed line, although it's probably hard to see because it's a black dashed line. Okay, but that dashed line is the boundary line between daylight and darkness, so that marks our terminator. Remember that our terminator is the boundary between daylight and darkness. I know it's kind of squished into the margin, but that's what that says. Okay, so I redrew the little person because you wouldn't be standing the same way in the southern hemisphere, and I'll show you what I mean in just a second. When the Earth is oriented this way, where the northern pole is tipped more towards the sun's rays, the northern hemisphere is going to have long days and short nights, and the southern hemisphere is going to have just the opposite, short days and long nights. Okay? All right, there's your answer for number 10. And let me show you what I'm talking about on the little globe and why they shouldn't draw the little stick figures the way they did. All right. All right, so here's our little globe. If you took two people standing at the equator and they walked backward towards the poles, they would wind up looking like this. They would not wind up with one like this and the other one like this, okay? Their feet both have to be on the ground. So change that orientation. Why does that matter? It probably doesn't matter too much for us. But for instance, if you were observing certain things like the phases of the moon and things like that, people in the southern hemisphere would see a waxing crescent moon, for instance, a little sliver of the moon. It would appear to them to be on, for instance, the left-hand side as they look up, whereas in the northern hemisphere it appears to be on the right-hand side of the moon. But anyway, just make sure that you make that little correction. Oh, my world's crashing. Anyway, and that should be it.